In this video, we will apply a concept of law of conservation of momentum to see if the collision that happened here between two objects experience what we call law of conservation of momentum, or conservation, or the momentum before the collision is the same as the total momentum after the collision. So this is the before collision, the state before collision happened, and this is after the collision happened. After the collision happened. Now, let us proceed by applying the concept of momentum, where we have the momentum of the first object is simply equivalent to mass and the initial velocity of the first object, which is represented by the uppercase letters m and v. Second one is simply lowercase m and lowercase v sub I, which represents the second object. If you notice, the first object is moving at 1 meter per second to the right, while the other object is moving at 1 meter per second, but this time is to the left, the opposite direction. By knowing that the other one is moving the opposite direction, to the left is negative, so we have to consider negative, and this one is positive. Negative and positive because of the concept that momentum follows the rule of direction, as the velocity is in terms of vector quantity. Now let us replace or plug in the values of m, which states that 2 kilogram multiplied by positive 1, and we have 1 kilogram multiplied by negative 1, where in this case we have 2 times 1 is basically 2 kilogram meter per second, and the other value is simply negative times negative, so negative 1, positive times negative, so that's negative 1 kilogram meters per second. So in order for us to figure out the total momentum before collision, so let's put it here, total momentum before. So by adding those two numbers, 2 minus 1, so this will give us 1 kilogram meter per second. So that is the total momentum in before collision. Now with this information that we have after collision, so let me just use a different color ink so it's easier for us to recognize the difference. So the momentum of object number 1 and the momentum of object number 2 after collision are as follows. So uppercase represents the first object, which is object number 1 on the left side, and multiplied by the final velocity v sub f after collision, lowercase m and v sub f for the second object. So let's plug in the values as follows. So we have 2 kilograms multiplied by 0.25, and since both of them are going to the same direction and it's positive because it's going to the right, then it's times a positive number. 1 multiplied by 0.5. Simplifying it mathematically, 2 times 0.25 is simply 0.5 kilogram meters per second. While the second object is 1 times 0.5, which will also result in 0.5 kilogram meter per second. As we take the sum, so this is our total momentum after collision. 0.5 plus 0.5 is definitely 1 kilogram meter per second. So as we answer this question, is the momentum conserved after collision? Okay. Yes, so the answer is yes, because the total momentum, so let's put it here, the total momentum is conserved. Total momentum of the system is conserved as shown in the calculation. Okay. Before collision, it's 1 kilogram. Before collision, total momentum is 1 kilogram meter per second. After collision, total momentum is also 1 kilogram meter per second. So this is an example where we can prove that momentum is conserved at before and after collision. But in the next video, we will discuss what are some of the conditions in order for us to maintain what we call a momentum that is equal, or momentum is conserved before and after collision, and that is something that we're going to discuss in the next video.